In this video, we're going to give some advice about how to balance chemical reactions. As we know, balancing chemical reactions is very important because the stoichiometric coefficients that result from balancing the reaction determine the relative amounts of reagents and products that react or are generated. Okay, so if you don't balance a chemical reaction correctly, then there's no chance that you can predict how much product will be formed or how many reagents you need to mix in order to be able to generate some given amount of product. Right, so we're actually going to be learning by doing. I'm going to write a chemical reaction that is very important in the metabolism in humans, and then we're going to take some steps to balance that. Right, so one of the favorite fuels that we have, that humans have, is glucose, this substance which is a solid. And when we burn this molecule for energy in our mitochondrion, we actually utilize oxygen, okay, through respiration. And this produces CO2, which is a gas, and water, which is a liquid, under physiological conditions. Right, so the goal then is going to be to balance this chemical reaction. Right, clearly the reagents and products are very obvious, and we also have the physical states. Okay, there's a solid, two gases, and a liquid. Okay, so the last thing that remains to be done here is to actually write the appropriate stoichiometric coefficients. So here are the steps. First, you need to identify the most atom-diverse molecule in the entire sequence. Okay, so we're going to look at the molecules and see which one seems more complex, the one that has more atoms. And well, CO2, water, they have two atoms, two elements. Oxygen only has one element, but then glucose has three, so this is clearly the most complex molecule. So tentatively, to start with, we're going to assign a stoichiometric coefficient of 1 for this particular molecule. Okay, so we just leave here a 1 and then worry about the rest. Then what we try to do is balance the atoms of this complex molecule in reagents and products. Okay, so let's start doing that. And we have 3 atoms to balance: carbon, hydrogen, and oxygen. The question is, which one of those will we choose? Well, we're going to leave for last the atom that appears in reagents and products as either a separated element, or an atom, or a homonuclear molecule. And well, carbon here is actually mixed with oxygen, so that is not pure carbon. Hydrogen is mixed with oxygen as well here, so that is not a pure element either. Okay, but we know that oxygen here appears by itself, right, as a homonuclear molecule. So this we're going to leave for last because it's very easy to wrap things up once you have only this element to balance. Okay, so that will leave for last, and we're going to start with carbon and then hydrogen. All right, so let's balance carbon first. We have 6 atoms of carbon here, and we can balance the number of carbon atoms in products by writing 6 in front of CO2. That will give us 6 atoms of carbon in products as well. All right, so the carbon atoms are balanced. Now we move on to hydrogen. Hydrogen, we have 12 atoms of hydrogen in reagents, and then we go to products. There's 2 for every water molecule, so we can write here 6, and then we have 12 atoms of hydrogen in products as well. So now we have that both reagents and products have the same number of carbons and hydrogens. Okay, so the last one that we have to balance is here oxygen, and again that is going to be easy to do because we have here oxygen by itself, so we just have to come up with a number right there that fits. All right, so let's count up the number of atoms of oxygen and reagents and products and see what this stoichiometric coefficient should be. Okay, in reagents we have 6 to start with, and in products we have 6 by 2, 12, 12 and 6, 18. Okay, so we have 18 atoms of oxygen in reagents. Here we have 6 atoms of oxygen, so we actually have to place here a number so that we can get 12 out of this, so that overall we have the same number of oxygen atoms, right? So the stoichiometric coefficient that we need right here is going to be a 6. Okay, the reaction is now completely balanced. Okay, and we're essentially done. Okay, it will not always be the case that the most atom-diverse molecule is going to have a stoichiometric coefficient of 1, like here for glucose. It will be often the case that we might actually need to have here a different stoichiometric coefficient, but you always start with a 1 for simplicity. Okay, a final couple considerations here. First, when we balance the reaction, we always have to use whole numbers. Okay, so you cannot use fractional numbers. And second, you have to use the smallest possible whole numbers that you can think of, right? So this reaction can also be balanced multiplying everything by 2 or by 3, right? You can say that the reaction will be balanced with 2 molecules of glucose, 12 of oxygen, 12 of CO2, and 12 of water. Okay, but those are not the smallest whole numbers. Okay, these are the small whole numbers. And again, the second consideration is that those numbers have to be integer. You cannot have fractional numbers. Okay, so hopefully this is providing some useful advice, and balancing chemical reactions just requires a lot of practice, so make sure that you practice with other examples.